fractions to decimals. Example 1. I'm not going to deal with the simple ones, over 10 or 100 or 1,000. I'm going to look at the harder ones. 7 over 20. Now, if we look at the denominator, the bottom part, you see that that number can be easily converted into 100 by multiplying it by 5. So, if I multiply the denominator by 5, and so it remains the same, the equivalent fraction, multiply the numerator by 5, I get 35 over 100. As a decimal, that is, you write the numerator, the top part, and then the denominator, the number of zeros in the denominator, tell you how many figures have to be after the decimal point. There are 2 zeros, so my answer needs 2 figures after the decimal point, so it goes there. So I've got 2 figures, the figure 3 and the figure 5 in that order after decimal point, and put a 0 in front. Example 2. $33 over 75. Now, this looks tricky because nothing immediately springs to mind as to what I can multiply 75 by to turn it into 100 or 1,000. But what I can do is, will this simplify down? Is there a common factor? Well, there is. 3 will go into both. So whenever you look at a fraction, always simplify it down first to see if it makes life easier. So I hope you're copying this down. 3 goes into both to give me 11 over 25. That's a nice straightforward one to turn into the denominator into 100. I times that by 4. And of course, I have to do the same to the top. So we get 44 over 100. So my answer is going to contain these figures. And the number of zeros, which again is 2, tells me the number of figures after the decimal point. So it's 0.44. Now, example 3. Oops, apologies. 5 over 8. There is a number that you can multiply top and bottom by. 1 or 2 of you may work it out. So that it's over 10, 100 or 1,000. But not all of you will. So here is our fallback. This always works when you're trying to convert a fraction to a decimal. We're going to use division. I'm going to divide the numerator by, to write this down, so you've got an example to look at, by the denominator. That is, I'm going to divide 5 by 8. Now, we're going to turn it into a decimal, so I'm probably going to have figures after decimal point. So I'm going to put a decimal point at the end after 5, and 1 in the answer row above. And I'm going to add a few zeros. I may not need all of these. I may need more. I may need fewer. Now, let's go through this then. 8's into 5. 8 won't go into 5. It goes 0 times remainder 5. 5. 8's into 50. Go 6 times. 6 8's are 48. So there's 2 left over. 8's into 20. Go 2 times. 2 8's are 16. So there's a remainder of 4. And, fortunately for us, it ends there. Because 8 goes into 5 8 goes into 14, my mistake, exactly 5 times. Now, the fourth case that you're going to deal with example 4. 3 over 13. I can't cancel it down. 13 doesn't look like, and we'll see later on, perhaps in another lesson, that it will never be turned into 10, 100 or 1,000 or 10,000, what have you. And we'll see why. So I'm going to use my fallback of long division. Inside it goes the top number, the numerator. Outside it goes 13. Put the decimal points in like so. Let's add a few zeros. And now, this is outside of our memorized times tables. So what I'm going to do is, I'm just going to quickly, I might need more, but I'm going to quickly write down the first few multiples of 13. So it's 13, 26, 39, 42. I might need more. So that's one lot of 13, two lots of 13, three lots of 13, four lots of 13. Put your hand down. Right, 3's into 30. Put your hand down. 3's into 13 into 3 goes 0. Remainder 3. Now, 13's into 30. Let's have a look. It goes 2 times. 2, 13's and 26. So there's a remainder of 4. Now, 13's into 40. Almost goes exactly. It goes 3 times. Remainder 1. 13 into 10. Won't go. Remainder 10. So I'm going to need a few more of those zeros. Now, I'm also going to need a few more multiples of 13. I'll have questions at the end just in case somebody's got any. You'll see why in a moment. So 65 is the 5th multiple, 78, 91 is the 7th one. For this particular one, investigating how many times 13 goes into 100, I won't need any more. So 13 goes into 100 7 times. 7 times 13 is 91, so I've got a remainder of 9. Oh dear, this seems to be going on and on and on. Now, 13's into 90. Well, 7 lots of 13 is too big, so it's going to be 6. Remainder, 12. I will need some more multiples of 13. What a good one to start with. 104. 9 lots are 117. Right, so look. How many times will 13 go into 120? It'll go 9 times. Remainder 3. Oh, it's my mistake. I messed that up rather badly, haven't I? So that should be a 0 I should have put there. And then that 9 should have been above it. And then the remainder was 3. And we can stop, because we're trapped in a loop, aren't we? This is going to keep recurring. We're never going to get out of the 230769. So 3 over 13 is 0.230769. And then would it carry on? And the way I show that is I put a dot above the first figure of the string that keeps recurring and a dot above the last. Okay, copy that down.